How can you explain multiplication patterns for even and odd numbers? Think about this question during the lesson. Nita says that the product of an even number and an odd number is always even. Is she correct? Even numbers are whole numbers that can be divided by 2 with none left over. Odd numbers are whole numbers that cannot be divided by 2 with none left over. What do you notice about the digits in the numbers from row to row? How can this help you understand even and odd numbers? From row to row, the ones digits stay the same, but the tens digits increase by 1. It is a pattern, so you know that all numbers with 2, 4, 6, 8, or 0 in the ones place are even, and all other numbers are odd.
Even numbers have 0, 2, 4, 6, or 8 in the ones place.
Two times 3 equals 6. 6 equals 2 times 3, so 6 is even. 6 times 3 equals 18. 18 equals 2 times 9, so 18 is even. 8 times 3 equals 24. 24 equals 2 times 12, so 24 is even. 2 times 5 equals 10. 10 equals 2 times 5, so 10 is even. 6 times 5 equals 30. 30 equals 2 times 15, so 30 is even. 8 times 5 equals 40. 40 equals 2 times 20, so 40 is even. 2 times 9 equals 18. 18 equals 2 times 9, so 18 is even. 6 times 9 equals 54. 54 equals 2 times 27, so 54 is even. 8 times 9 equals 72. 72 equals 2 times 36, so 72 is even.
Even numbers greater than 0 can be shown as 2 equal groups. Think about 2 times 3 and 2 times 5. 2 is an even number. 2 times 3 means 2 equal groups of 3. 2 times 5 means 2 equal groups of 5. There are always 2 equal groups, so the product of 2 times any number is even. You can generalize. All even numbers are multiples of 2. Think about 4 times 3. You can think of 4 as 2 groups of 2. Using properties, which is another way to write 4 times 3 equals 2 times 2 times 3.
Select your answer.
Using properties, you can write 4 times 3 equals 2 times 2 times 3 as 4 times 3 equals 2 times 2 times 3. So, 4 times 3 equals 2 times 6. There are 2 equal groups of 6, so the product will be even. You can write any even number as 2 equal groups. So, Nita is correct. Even times odd equals even. Now you know how you can explain multiplication patterns for even and odd numbers.
How are multiplying and dividing different with even and odd numbers? Let's look at the expression 3 times 7. 3 times 7 equals 21.
But can you divide 21 by 2 with none left over?
No. If you look at the factors, which are 3 and 7, you know that you can't divide 3 by 2 with none left over. And you cannot divide 7 by 2 with none left over. Both numbers are odd, and so is their product. You will also not be able to divide the product by 2 with none left over. You cannot divide odd numbers by 2 with none left over. What about 3 times 4? We cannot divide 3 by 2 with none left over. But we can divide 4 by 2 with none left over. The product is 12, which is even. You can divide even numbers by 2 with none left over. What other rules can you create about multiplying and dividing even and odd numbers? Write out your facts and look for new patterns.